Hey guys, we're going to keep going, and we're going to go to box plots. Okay, so let's talk about how to create a box plot. So remember we talked about our 5-number summary, which is our minimum, our Q1, our median, our Q3, and our maximum. So the first thing you're going to do is make a number line. And you might not want to do it by ones if you have data that ranges, say, from like 0 to 100. You could do it by tens. So make sure that either your horizontal or your vertical number line has a real number line. So then draw a small line segment above the number line to represent each number of the 5-number summary. So once you're done that, you're going to connect in a box the first quartile to the median to the third quartile. And then the min and the maximum, you're just going to put little lines to it. And let me show you what I'm talking about. Okay, so here we go. Draw a box plot to represent the 5-number summary from the previous example. So our 5-number summary was 12.1, 19.8, 23.6, 25.3, and 35.9. So they did it by 5s from 5 to 40, which is good. So then they put the little lines where the min, Q1, the median, Q3, and the maximum are. They joined Q1 to the median to Q3 and made a box. That's 50% of your data. And then they did the little lines. Okay? What is a box plot good for? It shows you how spread out the data is. So now here's a bunch of different box plots. And what they did is, I just taught you that you want to start with your minimum and your maximum. Well, sometimes you don't have to. If you have an explanation like you see out the side of here that has 10th percent is the bottom and 90 percentile is the top, you are more than welcome to do that. You just have to say that you're doing that. So if you look at these box plots here, let's ask a few questions. Which one has the largest IQR? Well, that would be the Missouri, because you're going to compare Q3 to Q1, with our Q3 being almost around, let's say, 0.6, and our Q1 being about 0.35. So play with these and play with them on Hawks, and you'll see how you can compare different data sets by using box plots. Okay? Quickly, standard score. When we were looking at empirical rule, I talked about this too. So you have two different formulas. Standard score for a population is given by Z equals X is the data value minus the mean minus the standard deviation. The sample standard score is the exact same. It's the data value minus the mean over the standard deviation. The formulas look different, but they are the exact same. Think about mean when they had different notation, but they meant the exact same thing. So think about it. Z equals the data value minus the mean over the standard deviation. So let's do an example. If the mean score of the math sections of the SAT test is 500 and the standard deviation is 150, what is the standard score for students who score 630? So my mean is 500, my standard deviation is 150. So I'm looking at that data value of 630. So I do 630 minus 500 over 150 gives you 0.87. You want to make sure to use parentheses on these, especially on that top where the data value and the mean are, so that you get the correct values. So the standard score for this one is 0.87, which means I know it lies above the mean and it's within the first standard deviation. Okay? So let's do this. Jody scored an 87 on her calculus test and was bragging to her best friend about how well she had done. She said that her class had a mean of 80 and a standard deviation of 5. Therefore, she had done better than the class average. Her best friend Ashley was disappointed. She only scored an 82 on her calculus test. The mean for her class was 73 with a standard deviation of 6. So who really did better on the test? Okay, so let's calculate each student's standard score or Z-score. Jody's standard score was calculated at the bottom. 87 minus 80 over 5 gives me 1.4. So Jody's standard score was 1.4. Ashley's, if you do it, 82 minus 73 over 6 was 1.5. So if you compare 1.4 to 1.5, Ashley actually did better and compared to with the mean of her class. Though Jody scored higher, when you compare it to the actual data that was for each class, you can see that she did better. Ashley did. I hope this helps. Let me know if you guys need any more, if you have any more questions or anything else you might need.